Welcome back to our channel. In this session, we will explore the ins and outs of Docker, discussing its advantages and disadvantages and showcasing real-time examples of Docker use cases. In the previous session, we discussed the essential tools and frameworks commonly utilized in microservices. If you missed it, I encourage you to watch Session 7 for a better understanding. Now let's dive in. What is Docker? Docker is an open-source platform that automates the deployment, scaling, and management of applications within lightweight, portable containers. Containers package an application and its dependencies together, ensuring that it runs consistently across different computing environments. This technology allows developers to create, deploy, and run applications in a more efficient and isolated manner.
Advantages of Docker. Portability. Docker containers can run on any system that supports Docker, regardless of the underlying infrastructure. This makes it easy to move applications between different environments, like development, testing, and production. Isolation. Each container runs in its own isolated environment, ensuring that applications do not interfere with each other. This is particularly useful for running multiple applications on the same host. Resource efficiency. Containers are lightweight compared to traditional virtual machines, as they share the host OS kernel and do not require a full OS for each instance. This leads to faster startup times and lower resource consumption. Version control. Docker images can be versioned, allowing developers to roll back to previous versions of an application easily. This aids in maintaining consistency and stability in deployments. Scalability. Docker makes it easier to scale applications horizontally by adding more container instances. Orchestrators like Kubernetes can manage container scaling automatically. Simplified deployment. Docker simplifies the deployment process by allowing developers to package applications with all their dependencies, making it easier to deploy applications across different environments. Ecosystem and community. Docker has a large ecosystem, including Docker Hub, which is a repository for images, and numerous tools and integrations that enhance its functionality and ease of use.
Disadvantages of Docker learning curve. For teams unfamiliar with containerization, there can be a steep learning curve. Understanding Docker concepts, commands, and best practices takes time. Complexity in orchestration. While Docker itself is relatively straightforward, managing multiple containers can become complex. Tools like Kubernetes or Docker Swarm are often needed for orchestration, which adds complexity. Security concerns. Containers share the host OS kernel, which can create security vulnerabilities if not properly managed. Misconfigurations can lead to security risks. Performance overhead. While Docker is generally lightweight, there can still be some performance overhead compared to running applications directly on the host OS, especially for I/O-intensive applications. Data persistence. Managing data in containers can be challenging. Containers are ephemeral, so data needs to be managed externally or through volumes, which can complicate data persistence. Limited GUI support. Docker primarily operates through the command line, which can be a barrier for users who prefer graphical user interfaces.
Real-time examples of Docker use cases. Microservices architecture. Many companies use Docker to deploy microservices, where each service runs in its own container. For instance, Netflix uses Docker to manage its microservices architecture, allowing them to scale and deploy independently. Continuous integration, continuous deployment, CI/CD. Organizations like GitLab and Jenkins use Docker to create consistent environments for testing and deploying applications. This allows developers to automate the build and deployment processes efficiently. Development environments. Developers can use Docker to create consistent development environments across teams. For example, a team working on a web application can use Docker to ensure that all developers have the same setup, reducing the "it works on my machine" problem. Data science and machine learning. Data scientists use Docker to package their applications and ensure that the same environment is used during development, testing, and production. This is particularly useful for reproducibility in experiments. Legacy application. Modernization. Organizations looking to modernize legacy applications can containerize them using Docker, allowing for easier deployment and integration with modern cloud-native technologies.
In summary, Docker is a powerful tool for containerization that offers many benefits, particularly in terms of portability, efficiency, and scalability. However, it also comes with challenges that need to be managed, especially regarding orchestration and security. In our next session, we will explore how to host a microservices application using Docker. If you enjoy the content and find it helpful, please consider subscribing to the channel. Your support means a lot and will help us create more informative and exciting content for you.